Hello! In this video, I would like to explain the relation between heavy spot position and vibrations in acceleration, velocity and displacement. Understanding of that will help you in balancing jobs. Let's imagine electric fan. It is not balanced. It means the heavy spot exists. If the rotor would be 100% balanced, then no vibration occurs. But in real world, always some residual imbalance exists. So everything vibrates. Now look at the animation. We can see the rotating fan with heavy spot and its movement or its vibration as you wish. Next to the fan, we draw the signal in time scale. It is like oscilloscope screen. Now we see the real movement amplitude. Now we amplify the movement to analyze it easily. What we can see in graph? Firstly, it is the maximum of movement in both directions. This line is the length of one rotation. We can measure it in time scale, for example 100 milliseconds. We can get the frequency in hertz. It tells how many rotations are during 1 second. It is better to use angular scale. One rotation lasts 360 degrees. One half lasts 180 degrees. 1/4 lasts 90 degrees. This approach has one main advantage. One rotation lasts 360 degrees always, independently of length in seconds. Now, please look in what time the maximum of positive displacement occurs. We should take notice where is the heavy spot in that moment. You can see that the heavy spot is in upper position. We can say that where the heavy spot is during rotation, there is also maximum of displacement. By other words, the displacement is in phase with heavy spot position. Now you can tell that the animation is fine, but is it true? I give you the evidence now. This is the real electric fan, and you can see the slow motion. The real speed is 10 Hz. Do you see the displacement maximum with heavy spot position? It is the same as in the animation. Now we explain the relationship between heavy spot position and phase. We use the displacement eddy current sensor. The tachosensor is used for measurement triggering. The red ray shines here on the rotor. We use the reflective tape for tachosensor. When the tape is going through the red ray point, the light is reflected and tachosensor creates the voltage pulse. This pulse triggers, it means starts, the measurement. Now I will show you several practical examples. Each example has 2 steps. The first is the graph on the analyzer and its description. The second is the application on the electric fan. For all measurement, we use the ADAS VA5 analyzer. You see the time signal and the amplitude and phase measurement below. It is amplitude and phase on speed frequency. The phase is difference between the trigger position and signal maximum position. Here we see the trigger marks or tacho marks, as you wish. It is the moments when the reflective tape was going through the red ray point of tacho sensor. It is happening one time in each rotation. The first trigger which starts the measurement is in 0 position. Now we can see the maximum amplitudes of signal, and the phase is the difference between them. Now we see the difference. It is the same for all displayed triggers. The difference is minus 74.4 degrees. It is almost exactly 1/5 of one rotation. How to understand that the value is negative? It means minus. You see that the trigger came 20 milliseconds before the signal maximum. The speed is 10.3 Hz. The length of one speed rotation is 97 milliseconds. The difference between trigger and maximum is 20 milliseconds. It is 1/5 of one rotation time. It means it is also 1/5 of 360 degrees, and it is 70 degrees. The heavy spot position on fan is not exact minus 70 degrees. It is minus 74.4 degrees. Now we decoded the value, but why minus? It is because the trigger time is less than signal maximum time. It means we need to deduct the value from signal maximum time. Of course, the minus 70 degrees is equal to plus 290 degrees. We can say that the trigger is delayed of 290 degrees. You can see in time signal that is just about our approach. We can measure time to the right or left. The range depends of analyzer type. Some of them uses minus 180 to plus 180 degrees. Others use range from 0 to 360 degrees. In ADAS instruments, you can choose your range. Now you can see the same situation in practice. The red ray point is in 0 degrees position. The reflective tape goes firstly through the red ray point. The heavy spot is going through the 0 degrees position now. The difference is minus 70 degrees. Now we better understand the plus and minus direction of phase. The analyzer displays minus 70 degrees in this case. It means we have to go 70 degrees against the rotation direction from the reflective tape position. And in this position the heavy spot is. You can see that it is easy to find the heavy spot position. In this graph is the tacho mark in the same position as the signal maximum. There is no phase difference. The phase value is 0. Now you can see again the same situation in practice. The reflective tape and heavy spot go through the red ray point together. The difference is 0 degrees. The analyzer displays also 0 degrees in this case. It means that the reflective tape position and the heavy spot position are the same. In this graph is tacho mark delayed by 70 degrees from signal maximum. The phase value is plus 70 degrees. Now the heavy spot is going through the 0 degrees position firstly. The reflective tape goes through the red ray point later. The difference is 72 degrees, but it is in the rotation direction. It means the value is plus 70 degrees. And we have to go 70 degrees forward in the rotation direction from the reflective tape position. In this position is the heavy spot. You can see that it is easy to find the heavy spot position. Now we understand that plus phase value means to go forward. It is in rotation direction. The minus phase value means to go back. It is against rotation direction. In this graph is tacho mark delayed by 180 degrees from signal maximum. But I can say that the signal maximum is delayed by 180 degrees from tacho mark. The phase value can be plus or minus 180 degrees. These both numbers are the same. Here is the practice example. Now we will look to the resonance. Everybody knows that the phase is changing of 180 degrees when the speed is higher than first resonance frequency. In this movie, the speed is lower than first resonance. You can see that the vibration and the heavy spot are in phase. The highest positive displacement occurs just when the reflective tape and heavy spot are going through the red ray point. Now the speed is higher than resonance frequency. You can see that the highest positive displacement occurs when the reflective tape and the heavy spot are on the opposite side. The phase changed of 180 degrees. It looks crazy. The heavy spot pushes down and the maximum displacement occurs in up direction. Now, probably many of you want to tell me that almost nobody uses eddy current sensors for balancing. Yes, you are right. But for basic explanation, is displacement the best physical quantity? Everybody can imagine the displacement. I am not sure whether everybody can imagine acceleration. In next part of Balancing Secrets video, I will show the measurement with accelerometer. I will talk about relationships between acceleration, velocity and displacement signals. So, see you next time and thanks for watching.